All right, so this is a little bit about naming acids, and I hope it helps. I'm going to play Jigsaw Falling into Place by Radiohead. All right, so for naming acids, you really should know your polyatomic ions, although polyatomic ions are not going to be in every acid. So if your acid does not have an oxyanion, okay, this is one thing that you're going to look for when you are naming acids. Look for an oxyanion. If we see all of these 5 acids, there are no oxygen atoms. The anions that there are, it would be like fluoride and chloride, bromide, iodide, cyanide. They all end in "ide," right? And so that "ide" ending is going to change. The basic name structure is hydroblankic acid. So for this one, HF, this anion is fluoride. So instead of fluoride, we do hydrofluoric acid. Make sure you put the U first. Hydrofluoric acid. Oh, that's a good way to remember it. No, U first. Something like that. Our next one is hydrochloric acid. That one everybody's heard of, right? Hydrochloric acid. I want to point out the aqueous in parentheses here. If hydrochloric acid, if HCl leaves water, if it's not dissolved in water, it's a gas. And we don't consider that an acid at that point. It might have some similar properties, but that, when you see it as aqueous, that's an acid. All right, so we got hydrochloric acid, hydrobromic acid, hydroiodic acid. All right, and then HCN is cyanide. It's a polyatomic ion. It doesn't end in ate. It doesn't end in ite. It ends in "ide." So this is going to be, instead of cyanide, we're going to use that root there, hydrocyanic acid. All right, so that's if you do not have an oxygen there, right? You do not have an oxygen. Another option is you do have an oxyanion, right? You have this anion like NO3 minus, right? Something like that. NO3 minus, NO2 minus, whatever. But you've got oxygen there in that anion. Well, then you need to remember this. And a wise teacher once told me this. Wise teacher who teaches next door. He said, you know, Poot, I ate ick to spite us. And I thought he was a little bit out there at the time, but as I thought about it, it made sense. And it connects ate and ick. And that's what you need to do. And it connects ite and us. And that's what you need to do too. So if you have a polyatomic ion that ends in ate, that ate part is going to change to ick. If you have a polyatomic ion that ends in ite, that ite part is going to change to us. And so here's your first part. If you have a polyatomic ion that ends in ate, your name structure will be blank ick acid. So for example, HNO3. Well, the oxyanion is NO3 minus. It's called nitrate. So it's nitric acid. HCO3, H2CO3. CO3 2 minus is called carbonate. So you get rid of the 8. And this is carbonic acid. Right? So this is the basic structure here. Carbonic acid. All right, and that works for... this is sulfate. This one's a little weird because it's sulfate, but it's sulfuric acid, right? You actually add that syllable back. That's okay. But you've heard of that. This is chlorate, and it becomes chloric acid. And phosphate becomes phosphic acid. Last thing, if the I didn't make it. Oh, darn. If the polyatomic ion in the acid ends in ite, the structure is blank us acid, OUS. So nitrite is nitrous acid, and that should be a little closer together, right? NITROUS. And then this is sulfite, and this is sulfurous acid. Again, sulfur, the sulfate and sulfite, they add back that syllable. Sulfurous acid. So if you know your polyatomic ions and you know whether they are ate or they are ending in ite, you can now name acids. The key to knowing that you have an acid, I hope if you read about this and maybe you've seen You see all my chemicals here? We've got this H in the front. Look for that. Acids are defined as being donating protons, donating an H+. And so that's what we see when we look at these chemical formulas all the time, right? We've got this H right out in front.